Good morning, all of you. I hope everybody is doing wonderfully well. Let us study law of conservation of energy, which is our second question, which we need to study. Okay, so one more time, physics first year question, 8 marks question, which is very, very important. Law of conservation of energy. So, law of conservation of energy. As I said earlier, you have to write the statement and then we have to prove it in case of freely falling body. So, what is statement here? That particular statement is energy neither be created or otherwise energy in the universe is constant. Universe is constant. That means you are not going to create new energy or you are not going to destroy it. Whatever the energy in this universe is, it is constant. So the first point is energy in the universe is constant, and second point is energy neither, here it is neither be created nor be destroyed. So whatever the energy it is there, that is going to be constant. You are not going to create new energy or you are not going to destroy it. But what you can do, you can transform from one form to another form. Okay. For example, electrical energy is there. Whenever you are using fan, it is being converted into wind energy. In that way, you can convert, and a part of it also becomes converts into heat, because whenever fan is continuously on, okay, if you touch that particular fan, what happens? You feel warm. Why? Because some part of electrical energy is converted into heat energy as well, along with the wind energy. In the same way, here also in mechanical energy, kinetic energy will be converted into potential, potential energy will be converted into kinetic energy. So now what we are going to write, okay, we can transform, but it can be converted. Okay, let us see, write like this. But it can be converted, it can be converted, not converted, okay, it can be transformed from one form to another form. So this is the statement. If you are writing this statement, you are going to get 1 mark. This is very, very important. Simple. There are numerous ways we have. Okay, we can write the statement, but it is a very, very simple way. There are only 3 points you need to keep in mind. One is energy in the universe is constant, and second one is energy neither be created nor be destroyed. Or you can write, if you are feeling very difficult to write neither nor, you write in simple terms. Energy cannot be created, energy cannot be destroyed, but it can be converted from one form to another form. You can write converted also, no problem at all. Okay, so whatever the thing you are writing, even though you are writing in your own words, the meaning should not be changed. That is the only thing you have to keep in mind. Okay, so this is law of conservation of energy. Let us prove it in case of freely falling body. Okay, in case of freely falling body, we are going to prove it. Assume that there is one particular object or a ball which is at point A at certain height from the base. Okay. Assume that this point is at a height of capital H. In some books they are taking capital H and small h. So there is a chance of confusion. So to avoid that, what I am doing, I am taking point A at height h and another point somewhere else here, point B, and the point C on the ground. Point C on the ground. Now the B is at a height of x. At a height of x. In some books they have taken it as small h, but there is no need to take like that. Okay, whatever the notation you are keeping, based on that you have to prove. So if this is the total height and this is the height x, then what would be the distance between A and B? That will be definitely h minus x. H minus x. So if you are drawing this diagram, you will get one more mark. That is what very, very important. Okay. So there is a particular object or a ball which is now going to be falling freely. While falling freely, we are calculating its total energy at point A, and after some time at point B, and finally we are calculating at point C. Now at point A, whatever we are getting, say for example, if we are getting mgh, the total energy, we should get mgh here as well and here as well. That means that is the first statement we have spoken about. Total energy in the universe is constant. So total energy at point A, point B, point C should be constant. Okay. Now let us prove it in case of point A. At point A. At point A. So mechanical energy is sum of potential energy and kinetic energy. So what is potential energy here at point A? We know the formula mgh, because mass of the object is m, and as it is going to fall down, gravity is going to act on it, so g, and A is at a certain height of h. So in this case it is mgh. Now what is kinetic energy here? What is the formula for kinetic energy? You know, half mv square. Half mv square. But see, at point A, the object is not moving. Okay. So it is stable. We are not leaving the object. At point A, we are holding it. So there is no velocity at all. Therefore, what happens? Velocity becomes 0. The total term becomes 0. Here, kinetic energy becomes 0. So total energy is equals to potential energy plus kinetic energy. Therefore, potential energy is how much here? mgh. And kinetic energy is 0. Therefore, whatever you are getting, that is mgh. This is the total energy. So at point A, what happened? Total energy is mgh, which is completely potential energy. There is no kinetic energy at all. So this is how we need to prove. So for this proof, you will get 1 mark. Now 3 marks we gain. Right? Note it down. Okay. Shall I have? Okay. Fine. Now let us see in case of point B. At point B. So at point B, what is going to happen? Now we are leaving the object. As soon as we leave, what happens? The ball is going to fall down. Now assume that the ball is reaching to point B. Now what is the potential energy here? So what is the formula for potential energy? mgh we know in general. But here, what is the height of the object? See, whenever you are measuring heights, you have to always measure from the base, not from the top. If you are measuring velocity, you have to measure from the initial position of the object. In this case, it is from A. So here we are measuring height, so you have to measure always from base. So from base to the point B, it is x. That is why here we get mgx. Potential energy is mgx. Now what is kinetic energy? Before going to find out kinetic energy, what we need to do is we have to calculate velocity of the object, because we know formula is half mv square, so we can't get directly v from here. So we have to use the equation v square minus u square is equals to 2as. Yesterday also we have seen how this is helpful while solving the work energy theorem. So that is why it is very, very important equation that you have to keep in mind. Here, see, initial velocity we didn't give anything, so u becomes 0. Final velocity v is v. Acceleration a is nothing but here acceleration due to gravity, and displacement s. Now, how much displacement the object got from A to B? What is the displacement here? H minus x. See, here in case of while finding potential energy, we have taken h value as x because we are measuring from the base. But here displacement we are measuring, so from A to B this is the displacement. That is why we are writing s is equals to h minus x. So now substitute all these things. What is going to happen? 2g h minus x. So v square is equals to 2g h minus x. Now find out kinetic energy. So kinetic energy Ke is equals to half m v square. That is equals to half m v square is how much here? 2g of h minus x. 2 get cancelled. Right. Now what we are going to have mg of h minus x. This is kinetic energy. Now what we need to do? Total energy. We have to find out total energy. So total energy is sum of potential energy plus kinetic energy. So total energy is equals to potential energy is how much here? mgx plus kinetic energy mgh of mg of h minus x. Now separate it. mgx plus mgh minus mgx. See, plus mgx minus mgx get cancelled. So remaining term is mgh only. So this is the required energy at point B. See, what happened here? Again the same thing, whatever we got at point A, now we also got at point B. That means energy is constant. But in this case, what happened earlier at point A, total energy is only potential energy. There is no kinetic energy. But now in the case B, what happened? There is potential energy and as well as there is kinetic energy. That means some part of potential energy is converted into kinetic energy. Right? So for this you will get 2 marks if there is no problem, or otherwise you will get 1 mark. Right? Note it down. Okay. Now let us see at point C. At point C. Again, same thing we have to do. Nothing new. Potential energy is how much? mgh. This is general formula. But here in this case, what happened? See, now the object is at point C. That means on the ground. So there is no height at all. H becomes 0. Therefore, here total potential energy becomes 0. And now what is kinetic energy? So before going to find out V, we have to use formula V square minus U square is equals to 2AS. Again, here final velocity V is equals to V, initial velocity. At point A we didn't give anything. And A is equals to G, but here S is equals to, what is the displacement of the object from initial point? From A to C, what is the displacement? Can we take H minus X? No, because it is a displacement from A to B. Can we take only X, which is B to C? No. From initial position we have to take. So from initial position to point C, what is the displacement? Capital H. So we need to write capital H. Now substitute all these things. V square minus 0 square is equals to 2GH. Therefore, V square is equals to 2GH. Okay, substitute it in kinetic energy formula. So, Ke is equals to half m V square. So, half m V square is 2GH. So 2 get cancelled, you will get mgh. This is kinetic energy. But At point C, what is the total energy? Total energy E is equals to potential energy plus kinetic energy. So potential energy is how much? 0. Kinetic energy is how much? mgh. So total energy is how much now? mgh. So this is equation number 3. At point C, the energy is mgh only. So at every point A, B, C, okay, we are getting same kind of energy. That means the total energy is constant. You are not going to increase or you are not going to decrease it. But what is happening? The energy is being transformed from one form to another. At point A, total energy mgh is only potential energy, but whenever the object reached to point C, the potential energy became 0 and kinetic energy became mgh. Whereas at point A, kinetic energy is 0. That means the total potential energy is converted into kinetic energy. In this way, hence, from equation 1, 2, 3, we can say that total energy is constant. For this, you will get 1 mark. Okay, so this is of 2 marks. If there is no problem, if there is a problem, you will get only 1 mark. In this way, we have to complete the answer, which is very, very easy. There is no hardship at all. See, first we have to define the statement, or you have to write the statement, then you have to draw the diagram, and then you have to prove it at point A, point B, point C, and then final statement. Keep in mind, while proving in case of B and C, you are using the formula B square minus C square is equals to 2AS. And one more important thing is, while measuring heights, always move from base to height. Okay, while displacement from initial position to final position. These are the 3 important points you have to keep in mind while proving it. Okay, there is no need to mark up, just go through it, practice it, okay, several times, and then write off your own, submit me the answers, I will check it and I will guide you further. Thank you very much.